back to my channel. Today we continue chapter 2 forces and motion 1 on topic 2.3 free fall part 2. So in this video I will discuss on the third learning standard, that is solve problems involving earth gravitational acceleration for objects in free fall. So in order to solve problems related to free falling objects, I hope you still remember what is the meaning of free fall. In my first video, I have discussed about free fall, concept of free fall, that is the object that experience gravity pull only. Okay, so the objects that experience free fall will experience gravitational acceleration, where we denote as G. Normally for the object under influence of gravity pull is object that thrown upwards or released downwards. Okay. So you look at this one, a tennis ball that thrown upwards. Direction upwards we assume as positive direction. Direction downward as a negative direction. So for thrown upwards and released downwards, it will experience gravitational acceleration and the value is always negative. We will discuss why the value of acceleration due to gravity is always negative. So the object that thrown upwards or released downward will experience uniform acceleration due to gravity. And that's the reason why we can apply the equation of linear motion in order to solve problems involving gravity pull. Look at here. I hope you still remember the linear motion equation. We have the first one. This is the first equation, second, third, and fourth. Okay, and I hope you also still remember the symbol that used in the equation. U is initial velocity, V is final velocity, A is acceleration. So in this case, A acceleration is called acceleration due to gravity, or we just take it A equals to G. Okay, and then T is time taken, S is displacement. So in solving problems, our assumptions are upward motion is motion in positive direction and downward is negative direction. Okay. Why acceleration for object thrown upward is negative? As you can see, when object thrown upward, it will start with certain value of initial velocity, and the value of velocity will decreases and become zero at maximum height, or the tennis ball will experience deceleration. So the sign for the acceleration will become negative. So for object that thrown downwards, this one is against the direction that we assume as positive. So this one is negative direction. So that's the reason we take it as negative value here. Or we can say accelerate in opposite direction or accelerate in negative direction. So let's look at the first example. Amira threw a ball vertically upwards with an initial velocity of 10 meters second to the power negative 1. Calculate time for the ball to achieve maximum height. B. Maximum height that can be reached by the ball. Ignore air resistance. G equals 9.81 meters second to the power negative 2. The word ignore air resistance means this is a case of free fall. Thus, the acceleration due to gravity G is equals to 9.81 meters second to the power negative 2. So you just use the value that given here. Okay, so this one is case the ball vertically thrown upwards. Okay, now let's try to solve this question. So ball move upwards, U is positive but G is negative. So remember, the acceleration due to gravity is always negative. Okay, try to solve this one. At first, we try to list out all the information given. So initial velocity u is 10 meter second to the power -1. Final velocity at maximum height is 0. When reach maximum height, the ball will be at rest for a few seconds, or we can say the final velocity becomes 0, and then it will drop. After the maximum height, it will drop and return the ground. Acceleration g is negative 9.81 meter second to the power -2. So what formula that we can choose to solve this one? So we have all the information except s, no s. So we use the first equation, v equals to u plus at. Now a we substitute with g, because this one is case of free fall under influence of gravity pull. So v equals to u plus gt. Final velocity at maximum height is 0. Initial is 10. G is negative. So you must put negative sign. Negative 9.81 t. Then you get t equals to 1.02 second. So we get the time for the ball to achieve maximum height. Okay, now we want to find maximum height. So v square equals to u square plus 2gs. Okay, final velocity at maximum height is 0, initial is 10, plus 2 times negative, must put the negative sign, s. Thus we get s equals to 10 squared divided by 2 times g, or 9.81. Thus we get 5.10 meter. So this is the maximum height. Okay, actually we can use other formula. Okay, if we have enough information, we can choose to use another formula. We have 4 formula in that linear motion equation. So if you want to use this formula also can. For example, s equals ut plus half gt squared. Okay, you have the value of u, then you have the value of t from here. Okay, and then g is negative 9.81. Then you get the same answer, 5.10 meter. If you don't put the negative sign, the answer will be different. So make sure you understand the concept of free fall and the direction that you need to use for G in the case of vertically upwards. Okay, so we can conclude from this example that for the case of thrown upwards, you can see the value of S positive, G always negative, V positive, and U is positive. Okay. Example 2. Chan released a stone from cliff of 10 meter height. Determine A, time taken for stone to reach the bottom of the cliff. The velocity of the stone just before it touches the ground. Ignore air resistance. G equals 9.81 meters second to the power -2. Solution. So for this example 2, you can list out all the information given. So this one release case. So initial velocity equals to 0. The value of s negative because the downward direction is negative. So s is negative 10, u 0, t plus half, g is always negative 9.81 t squared. Okay, you solve for t squared, you get t equals to 1.43 second. B, to find the velocity of stone just before touches the ground, meaning the final velocity. Initial velocity equals to 0. So v squared equals to u squared plus 2gs, u equals to 0. So we have v squared equals to 2 times negative 9.81 times negative 10. Okay, remember g always negative and s is negative because downward direction is negative. And then you solve for v, you get plus minus 14 meters second -1, and the velocity here is equals to negative 14 meters second -1. Why we take the negative value? So V equals positive value 14 is ignored because the stone moved downwards. As I mentioned earlier, direction downward we take as negative direction. So sign for S is negative, sign for V also negative. And of course for G, always negative. Okay, another equation that can be used is V equals to U plus GT. U equals to 0, then V equals to negative 9.81 times 1.43. T we already calculated from here. So we get V equals negative 14 meters second to the power negative 1. So for this case 2, release of form, we can conclude that the sign for S is negative, G always negative, V is negative, and U is always 0 for the case of release or fall. Okay, formative practice 2.3, let's look at number 1, what is meant by free fall. Just look at the definition for free fall. So an object experiences free fall if the motion of the object is affected only by gravitational force, or the motion of an object due to gravitational force only. Okay, this one is definition. You need to memorize. Number 2, a light hollow plastic ball and solid steel ball of the same size are released from cliff of a hill. Will both balls reach the foothill at the same time? Explain your answer. I hope you still remember in my first video, I have shown you when the feather and the steel ball drop in vacuum. Both will fall at the same rate and reach the ground at the same time. So that one shows that the acceleration due to gravity does not affected by mass of the object. Okay, so from here we can write down the answer. Both reach at the same time because gravitational acceleration does not depend on mass, and both balls experience same air resistance. They have same size and same shape, of course, because this one is ball. Okay, so they will reach the ground at the same time. Okay, number 3, an object thrown vertically upwards reach maximum height of 5 meters. Calculate A, the velocity of the object when thrown. The time taken for the object to reach its maximum height, the time required for object to return to its original level. Ignore air resistance. So this one is free fall. So G equals 9.81 meters second to the power negative 2. Okay, list down all the information given. So at maximum height, the final velocity equals to 0. Displacement S is 5 meters. So you must put positive sign here because direction upward is positive. G always negative, so negative 9.81 meters second to the power negative 2. So we use the fourth formula of linear equation. So we have V squared equals U squared plus 2ES. The final velocity is 0. Thus we get U squared equals to 2 times 9.81 times 5. Here there's a negative sign. Now I bring it the mathematical operation. So I get U squared equals to 2 times 9.81 times 5. That is 98.1. Thus we get initial velocity equals to 9.905 meters second to the power negative 1. So this one is the velocity of the object when thrown, or we call it initial velocity. So B, time taken to reach maximum height. So at maximum height, V equals to 0 just now. We have calculated the value of U also. Now we can use the first equation. V equals U plus AT, or V equals U plus GT. Remember, the value of G always negative. Thus, we get T equals 1.01 second. This is initial velocity that calculated from here. Okay, so you get the answer. T is time taken for the object to reach its maximum height. Okay, C, the time required for the object to return to its original level. Meaning once reach the maximum height, after that the ball will drop or fall back to the ground. So what is the time taken to return to its original level? So this one is C. So negative 5 equals 0 plus half gt squared. This is what formula? This is the third formula. S equals to ut plus half gt squared. S is negative because move downward to return to its original level. Okay, so negative 5 equals 0. Fall, so u equals to 0 plus half. G is negative 9.81. Then you find t, so you get t equals 1.01 second. So the time taken to reach the maximum height and the time required for object to return to its original level is the same because the object experiences uniform acceleration due to gravity. Okay, so the total time taken for the object to thrown upwards and returns to its original position is 2 times 1.01 second. That one will become 2.02 second. That one is total time taken. Okay, so but this one is just time required for object to return to its original level. So meaning t equals to 1.01 second. So the object is moving upwards and downwards with same constant acceleration due to gravity. That's why the time taken here are the same. Okay, number 4, a tennis ball that is released falls vertically from a building of height 50 meter. Calculate time taken for the ball to reach the base of the building, the velocity of the ball just before hitting the base of the building, the vertical distance passed at the third second. This is also a free fall case. Okay, now we'll list out all the information. Initial velocity 0 because release or fall downwards. Okay, S positive value 50 meter, G always negative, negative 9.81 meter second to the power negative 2. Okay, now based on the information given, we can choose the formula that we want to use. S equals to ut plus half gt squared. Okay, this one fall downward is negative direction, so S must put negative sign here, fall downward. Okay, negative sign for S, and then G also negative. This one I forgot to write down the negative sign, so you must put negative sign. Downward, remember, downward. So S is negative 50, U0 half GT squared. G is negative 9.81. Thus you get T equals 3.19 second. That one is time taken for the ball to reach the base of the building. And then B, velocity before hitting the base of the building is the final velocity. So V equals to U plus AT. Initial velocity 0. G is negative 9.81. And then T 3.19 from here. So the value of V that we get is negative 31.32 meter second negative 1. Because direction downward is negative, so the value of V is negative. And then C, the vertical distance passed at third second, not after 3 seconds. This one is at the third second, so we need to calculate in that third second only. So time distance travel in 3 seconds we can calculate by using S equals ut plus half gt squared. In 3 seconds, so we substitute the value of t as 3 seconds. So we label it as S3 equals to U0 plus half G negative 9.81 times 3 squared. And then S2 we calculate using the same formula, 0 plus half times negative 9.81 2 squared. Okay, so vertical distance at the third second is S3 minus S2. because we want to find for at that third second only. So S3 minus S2, thus we get this formula or this step, half times negative 9.81 times, this is factorized mathematical operation. So we get half times negative 9.81 times 5. So we get negative 24.53, and the value is negative because direction downward is negative. Okay, so we already solved this one. As you can see from all the example and exercise that we have discussed before, all shows that value of g is always negative. Why it's always negative? Because upwards decelerate, downward accelerate in negative direction. So both must put negative sign. So I hope you can understand about this problem solving by using the linear motion equation. For the free fall case, don't get confused. You must get familiar with the sign. Okay, so I will stop here. I will continue in the next topic, in my next video, 2.4 initial. Okay, bye.